Hello, thank you for watching this video. So in this video we're doing question 8 of November 2024 question paper mathematics paper 2, and the topic is 3D application of trigonometry, right? So I'm going to read question 8 statement and then answer the questions that follow. So let's go. They're saying in the diagram, C is the foot of a vertical building and D is the top of the same building. The height of the building CD is 16 meters. Two observers are standing 19 meters apart at point A and B, where A, B, and C lie on the same horizontal plane. A painter working at point E on the a painter is working at point E on the building. The angle of elevation of D from point A is 46.85 degrees. We are told that angle E, which is the angle between DE and EB, is 122 degrees. And angle C, which is the angle formed by line BC and CA, is 105.61. So let's look at this. What are they saying? They're saying the diagram, this point here is the foot of the building, this is the base of the building, this is the ground, right? And they're saying D is the top of the building. So it's more like some sort of a corner of a building here. So this is the or maybe not necessarily a corner, or actually it is a corner. So you are here, this is point C, which is the bottom of the building, and that is the top of the building, right? So they are telling that there are observers, which means at A and B, right? And these two guys are 19 meters apart. So this is 19 meters. So these two guys are 19 meters apart. This building of yours is 16 meters tall, right? No problem. They went on to tell you that A, B, and C are on the same horizontal plane, which is they form the base, they're on the ground, they're all on the floor. I will try to draw something that I think will show this clearly. And then they're giving you that this angle is 122 degrees, and this one, which is the angle between BC and AC, is 105.61. So they told you also that the angle of elevation is 46.85. So I want to try to draw this kind of situation using the building. Like I will try to draw a building. I don't even know how to draw, but I will try. So let's say this is a face side of a building. You can see there's a window. Let's say there's another window here. Maybe let's make 4 windows, right? So this is the side of a building, and this is another side of a building, maybe. This is another side of a building. So let's make a window here and a window there. So of course this building extends to the back, right? So this is the view that we have here. So it's the side and the side. So this is on the ground, of course. This is the ground, right? So this is your point C over here. And they're telling you that the height of this building is 16 meters, which is what you can see over there, right? Then they're saying there's someone here at point E. They're painting the building here at point E. Point E is here. So they're pointing the building here. As they're painting this building, there are two guys, which is one sitting here and one maybe standing there. They're both standing at these positions. And they are 19 meters apart. So these two, they are observers, which is they are watching this guy that is painting there. So this guy A and this guy B, they are watching the painter that is there at E to see if maybe they're doing a good job. You can think of them maybe as supervisors. So now you can see they're on the ground, and so is that. So all of these three A, B, C, they're all in the ground. So they're all in the same surface. Fine. So now you are told that the angle between BC and your AC is what? Is 105.61, maybe. Yes. And you are told that the angle of elevation, because this is point D up there, the top. So the angle of elevation, which is can see the angle of elevation, the angle measured from the horizontal up to the line. So an angle of elevation is the angle measured from the horizontal, is a measure from the horizontal. So this is the ground, right? This shaded part. So the angle from the ground to point D is 46.85 degrees. Right? And also you are told that of course this guy is looking there, and the angle is this one over here. So we're given this outside angle, which is 122 degrees. That's what we're given. I think I've just redrawn that. So I was trying to give a clear view. Maybe I should have just drawn it once. So this is the situation that we have here. But what I've done, I've just removed the building and only left the triangles only. That's what I did. I removed all the buildings because there's no building. And then I've just drawn the triangles only. That's what I did here. So I'm going to work with this because I don't want to be having a lot of things with buildings and all other stuff. So what are they saying at 8.1? They are saying calculate the length of AC, the distance between the observer, A, and the foot of the building. So they want us to find AC, right? Here's AC. As you can see, there is AC as well, which is the distance, because this is the base of the building. This is the base or the foot of the building, the ground. And this is where another supervisor is sitting. So they want to know how far is the supervisor from the building. That's what they're trying to find. Right? Fine. So if you're looking, if you are the supervisor, you are here, right? So you can see that supervisor is supervisor is sitting here. If you want AC, which is this length over here, you have this angle on this triangle, on this black triangle over here. So we have this angle here, and what kind of triangle are you on? ADC is a right angled triangle, right? This is a right angled triangle. There is a 90 degree. There is a right angle over there. So you know, if you have a right angled triangle, you can use your trig ratios, which means your sines, your coses, and your tans, right? Your trig ratios. That's what you can use on a right angle. So if you are at this angle, angle A, which is that's where the guy is sitting, you are given the opposite side, right? And you want the adjacent side. The trig ratio that relates or that connects the opposite side to the adjacent side is the tangent, is tan. So you know that if you say, okay, tan of angle A is going to be called to the opposite over the adjacent, right? What is your opposite? Your opposite is DC all over your adjacent, which is AC, which is what you're asked to find. So say tangent of A, what is your A? Your angle A is 46.85, right? Tau is equal to DC. What is your DC? You're told that DC is the height of the building. I did tell you that DC is the height of the building. It's 16 centimeters, 16 meters. So 16 meters over AC. Then all over 1, you cross multiply. Get that AC tangent of 46.85 is equal to 16. You divide by the tangent both sides. You get that your AC is equal to 16 over the tangent of 46.85. That's what you have. So the value of AC will be the answer to this. So let's go and find that answer. So 16 over the tangent. 16 over the tangent of 46.85. So you get that your AC is equal to 15 meters. So our AC is equal to 15 meters. I'm going to use the green ink so that we see that we calculated this. So this is 15 meters over here. That is our AC. Fine. We're done with 8.1. Now let's go to 8.2. Okay, at 8.2 they're saying calculate how far the painter at E is from the top of the building. They're asking you to calculate how far the painter E is from the top of the building. So your painter is sitting here at E, right? So they're asking how far is this person from the top of the building. So they want this distance DE. Because they're asking, because you know that this is 16 centimeters, right? 16 meters. And we have painter E here. So they're asking how far is this painter from the top of the building, which is they're looking for the distance DE. That's what they're looking for. They're looking for DE. Because if your painter is up here and you know the entire thing is 16 centimeters, they want how far the painter is from the top. They want this distance over here. So what you need to know this distance, EC, right? Once you know your EC, you can subtract from 16 to know what DE is. That's what we're going to try to do. Fine. How can we find DE? Or EC? Or maybe DE? So what we're going to do, we're going to try to find EC. After finding EC, we're going to find DE by subtracting the EC from the entire length of the 16 centimeters. So how are we going to go about this? What we're going to do, let's find this side first, which is BC. Once we find BC, we'll be in a right angle triangle, which is BEC. We'll be on this BEC, and we'll be having this side. And we can try to find angle E, because we know angle E, this inside E and the outside E, they add up to 180 degrees, because those are angles in a straight line. Right? So, first, and after finding it, then we can apply the same trig ratio similar to what we have done here, because we'll be having this side, wanting this side, and we'll be having that angle over there. So which means we'll be having the opposite, wanting the adjacent, which is EC. That would be a term. So let's first find BC. So BC is where? Is in triangle ABC. So let's say in triangle ABC, how do things look like? A triangle ABC, we can say this is a small c, this is A, this is your small a, and this is B, this is your small b, which is your AC is your small b. Right? So you can use, what is this thing? You can use the cosine rule. What we want this guy over here. We want A, but we have angle C and this corresponding side. So we can say on a cosine rule, you know that if you're using a cosine rule, this is how it works like. Let's say you have A, B, C. This is a small letter A, this is a small letter C, and this is a small letter B, right? On this triangle. So if you want, let's say angle A, if you want angle A, okay, let's say we have angle A and this corresponding side, right? So what will happen, it will be your A squared is equal to, because you have this angle here. Let's say you have this angle here. So it will be your A squared. Okay, so what I'm trying to say, if you have angle A, your formula for, depending on what you're looking for, your A squared will be equal to these two sides that are bounding A, or that are forming angle A, which is your B squared plus your C squared minus 2BC times cosine of angle A. Right? If you have angle C, your formula, your cosine rule formula, it will be this side squared, which is the side opposite the angle that you have, is equal to the sum of the squares of the sides forming angle C, which means your A squared plus your B squared minus 2AB cosine of C. And then if you have angle C, so if you have angle B, so you use that side, which is your B squared, is equal to the sum of the two sides forming B, which is your A squared plus your C squared minus 2AC cosine of angle B. This is how the cosine rule works, right? So, in this case, we have this angle C. So, which means our C squared is equal to what? Called A squared plus B squared minus 2AB cosine of angle C. We have C, we don't have A, we have B, we don't have A, we have B, we have that. So we can substitute everything that we know, and we're left with what we don't know. So in that case, what is your C? Your C is equal to 19 squared is equal to your A squared. You don't have anything, just put A squared plus your b squared. Your b squared is 15. So we just found 15 squared minus 2a times b, which is 15, times cosine of what? Times cosine of 105.61. Because that angle over there, angle C. Then we're looking for a. So we can try to simplify from here and see what we get. What is your 19 squared? 19 squared is 361. 361 is equal to your a squared plus 225, 15 squared minus 30 cos 105.61 a. Right? So let's take this to the other side. So you have 0 is equal to your a squared, right? Let's punch this as negative. Let's punch this negative 30 cos 105.61. Negative 30 cos 105.61. What do we get? We get positive 8.07 a. So it will be 225 minus 361, because this will become negative. So you have 225 minus 361. You get minus 136. So you're trying to find a, right? Because this is your quadratic. Your a is called negative b, which is 8.07 plus or minus square root of 8.07 all squared minus 4 into a, which is 1, into c, which is minus 136 all over 2 into 1. Your a is equal to, or your a is equal to. So negative 8.07, right? So what do we have? So we'll say negative 8.07 plus, let's this, square root 8.07 all squared minus 4 into a and 6 minus 136 over 2. So you get that your a is equal to 8.30, or our a is equal to what? Minus 16.38. So a is what? A is the length BC. And you know, a distance, a length is non-negative, right? So it can't be this one. Therefore, your BC is equal to 8.30 meters. So we got that the BC here is equal to 8.30 meters. This is the length of BC. So what do we do now? Let's go and find this length EC. I'm going to clean that. I'm going to clean my drawing now. I think at least we understand what is happening. Okay, so what do we do? We say, okay, we can say, okay, this angle here, which is angle E, which is DEB, which is DEB, which is angle, when you say write it like this, the angle between DE and EB. DE is this one, EB is that one. Plus what angle? Plus this angle here in this triangle, which is BEC. Plus BEC is equal to 180 degrees. These are angles on a straight line. Right? Your DEB is called 122 plus BEC is called 180 degrees. Therefore, your BEC is called 180 minus 122 degrees, which is 58 degrees. So, we know this inside angle over here is 58. So, we have this angle here, we have this angle on a right angle triangle BCE. On right angle triangle BCE, we have the opposite side and we want the adjacent side. Same thing that we did on the first triangle. So that is the tangent. So we can say the tangent of angle E, or maybe your BEC, to be specific, BEC is equal to your opposite side, which is BC, over your adjacent side, which is The opposite side is BE, adjacent, oh, it's BC, yes, over adjacent side, which is EC. Right? So, the tangent of 58 is equal to BC, which is 8.3 over EC. You get that your EC is equal to the answer to, or you cross multiply. EC tangent of 58 is equal to 8.30. Divide by tan both sides. Your EC is equal to 8.30 divided by tangent of 58, which is your 8.30 8.30 divided by tan 58. You get that this is 5.19 meters, right? So we get that EC, which is this small length over here, is 5.19. This small length over here, 5.19. And we know that the entire length DC, so your DC is made up of what? Of DE plus EC. You can see this from your diagram, right? So your DC, entire height, call it DE and EC. So which is your DC is 16 meters is equal to your DE, which is what you're trying to find, plus your EC, which is 5.19. So for your DE, you find that your DE is equal to 16 minus your thing. So it's 10.81 meters. So that's how I would have done this question. And I'm done with this. And I hope it does make sense to you, as it does to me. If you want to attend our classes, see the information on the description. And we're done here. Thank you for watching. Cheers.